The Kuiper Belt, often referred to as the third zone of our solar system, is a vast and largely unexplored region that lies beyond the orbit of Neptune. This region, first hypothesized in 1951 by the Dutch-American astronomer Gerard Kuiper, is home to a wide variety of icy bodies, dwarf planets, comets, and other small solar system objects. The Kuiper Belt, along with the Oort Cloud further out, plays a significant role in shaping our understanding of planetary formation, the early solar system, and the ongoing processes that continue to evolve in space. In this detailed exploration, we will delve into the discovery, structure, significance, and characteristics of the Kuiper Belt, examine its place in our broader understanding of the solar system, and discuss the ongoing scientific exploration that continues to unlock the mysteries of this distant frontier. The concept of the Kuiper Belt arose from the need to explain certain anomalies in the solar system. During the 20th century, astronomers began to notice that there were more small bodies in the outer solar system than previously thought. In 1951, Gerard Kuiper proposed that a population of small icy bodies existed beyond Neptune, but at the time, there was no direct observational evidence to support his hypothesis. The first actual discovery of an object in the Kuiper Belt did not occur until 1992, when astronomers David Jewitt and Jane Liu identified a small object beyond Neptune. This marked the beginning of modern exploration into the Kuiper Belt. The object, 1992 QB1, was the first confirmed Kuiper Belt object, KBO, and its discovery marked the start of an entirely new field of planetary science. Over the years, as telescopes and detection techniques improved, astronomers began to find thousands of similar objects in the region, confirming the existence of the Kuiper Belt. Today, the number of known KBOs exceeds 3,000, with many more anticipated to be discovered as technology advances.
The Kuiper Belt is a vast region that stretches roughly from 30 to 55 astronomical units, AU, from the Sun. To put that in perspective, Earth orbits the Sun at $1 Australian, while Neptune is located at an average distance of 30 Australian dollars. The region is populated by icy bodies, including dwarf planets, comets, and other small objects that are remnants from the early days of the solar system. The Kuiper Belt is typically divided into two main regions. The classical Kuiper Belt, which extends from approximately 30 Australian dollars to 50 Australian dollars from the Sun objects in this region, also known as cold KBOs, typically have relatively stable orbits and are not significantly influenced by gravitational interactions with Neptune. The majority of the objects in the classical Kuiper Belt have near-circular orbits and are thought to have been in their current locations for billions of years. The scattered disk is a more distant and dynamically unstable region that overlaps the classical Kuiper Belt. Objects in this area, known as scattered KBOs, have highly eccentric orbits, and their trajectories are often influenced by gravitational interactions with Neptune. Scattered KBOs are more prone to being scattered into the inner solar system or even ejected from the solar system entirely. Within these regions, there are also objects that are classified as resonant KBOs. These objects are in orbital resonance with Neptune, meaning their orbits are synchronized with the planet's motion in such a way that gravitational interactions with Neptune maintain their orbits in stable configurations. For example, the dwarf planet Pluto is in a 2:3 resonance with Neptune, meaning that for every 2 orbits Pluto makes around the Sun, Neptune completes 3. While the Kuiper Belt is home to an enormous variety of objects, a few notable ones have garnered significant attention from scientists. Some of these objects, such as Pluto, Haumea, Makemake, and Eris, are large enough to be classified as dwarf planets. Pluto, perhaps the most famous object in the Kuiper Belt, was once considered the 9th planet in the solar system. However, in 2006, Pluto was reclassified as a dwarf planet by the International Astronomical Union (IU). Pluto's orbit is highly inclined and moderately elliptical, taking it inside the orbit of Neptune at certain points in its orbit. Despite this, the 2:3 resonance with Neptune ensures that the two bodies will never collide. Haumea is an elongated, egg-shaped dwarf planet that is also located in the Kuiper Belt. Haumea is unique because it has an extremely fast rotation period, completing a full rotation in less than 4 hours. This rapid spin contributes to its elongated shape. Haumea is also notable for having a ring system, making it one of only a few known objects in the solar system to possess rings. Eris is a distant, icy body that was discovered in 2005. It is slightly smaller than Pluto but is more massive, and its orbit takes it far beyond Pluto. Eris's discovery led to debates about Pluto's planetary status and was one of the key factors that led to the reclassification of Pluto as a dwarf planet. Makemake is another dwarf planet in the Kuiper Belt, discovered in 2005, shortly after the discovery of Eris. It is slightly smaller than Pluto and has a similar composition, consisting mainly of rock and ice. Although not a member of the Kuiper Belt proper, Sedna is often discussed in relation to the region. Sedna is a Trans-Neptunian object with a highly elliptical orbit that takes it far beyond the Kuiper Belt, out to distances as far as 900 Australian dollars from the Sun. It is thought to be part of the extended Kuiper Belt population, which is sometimes referred to as the inner Oort Cloud. The Kuiper Belt offers valuable insights into the early solar system and the processes that led to the formation of planets. The objects in the Kuiper Belt are remnants from the time when the solar system was still forming, and their composition and structure can provide important clues about the conditions that existed in the outer regions of the early solar system. Scientists believe that the Kuiper Belt objects were formed from the primordial material that never coalesced into a planet due to the gravitational influence of Neptune. The interactions between Neptune and these icy bodies, combined with the lack of material in the outer solar system, led to the formation of small, icy objects that remained in the region. The study of the Kuiper Belt also helps to explain the structure of the outer solar system. For instance, the presence of large icy bodies like Pluto and Haumea supports the idea that icy bodies were more abundant in the outer solar system than rocky bodies, providing a contrast to the inner terrestrial planets. The Kuiper Belt is often discussed in conjunction with the Oort Cloud, a much more distant and spherical region of icy bodies that lies far beyond the Kuiper Belt. The Oort Cloud, which is believed to be the source of long-period comets, extends from approximately 2,000 to 100,000 Australian dollars from the Sun. While the Kuiper Belt is relatively flat and lies in the same plane as the solar system's planets, the Oort Cloud is thought to be spherical, with objects scattered throughout. The relationship between the Kuiper Belt and the Oort Cloud is an area of active research. Some scientists believe that the Kuiper Belt may have been the source of many of the objects in the Oort Cloud, with gravitational interactions over time causing objects to be scattered to more distant regions. While much of the Kuiper Belt remains unexplored, several key missions have provided valuable data and increased our understanding of the region. Launched in 2006, NASA's New Horizons spacecraft made a historic flyby of Pluto in 2015, providing detailed images and data of Pluto, its moons, and the surrounding region. After its flyby of Pluto, New Horizons continued its journey into the Kuiper Belt, performing flybys of other KBOs, including Arrokoth. This mission has provided some of the first close-up images of Kuiper Belt objects and has opened up new avenues for exploration. Several future missions are planned or proposed to explore the Kuiper Belt further. The James Webb Space Telescope, for example, will provide valuable infrared observations of the region. Additionally, missions like the proposed Kuiper Belt Interstellar Probe aim to reach beyond the Kuiper Belt to explore the outer limits of the solar system. The Kuiper Belt plays a critical role in our understanding of the solar system, not only because it contains ancient, primitive bodies that provide a glimpse into the past, but also because it offers insight into the evolution of our planetary system. The study of the Kuiper Belt enhances our understanding of planetary dynamics, the distribution of matter in the early solar system, and the processes that govern the formation and evolution of planetary bodies. In addition to its scientific value, the Kuiper Belt is also important for the future of space exploration. As humanity continues to explore deeper into space, the Kuiper Belt may serve as a key region for future exploration and resource utilization. The Kuiper Belt is a fascinating and essential component of the solar system, home to a diverse population of icy bodies that provide critical insights into the history and evolution of our planetary system. Despite being one of the least explored regions in our solar system, the Kuiper Belt continues to captivate scientists and astronomers, offering new opportunities for discovery with each passing year. As technology advances, we are poised to learn even more about this distant frontier, deepening our understanding of the solar system and the universe beyond.